Hello everyone, we're now on the third factoring technique, which is about factoring sum or difference of two cubes. In this lesson, you should know how to identify perfect cube as well as how to get their cube root. This topic is actually the direct opposite of the product of the form, the quantity x plus or minus y times the quantity x squared minus or plus xy plus y squared. Recall that when we multiply this kind of polynomial, the result is a special product, which is a sum or a difference of two cubes. From the name itself, the two given terms are perfect cube and that they are separated by either plus or a minus sign. This time, we will be given that kind of special product and we will going to express it as a product of these two polynomials. Before we discuss some examples, let's have a quick recall regarding perfect cube. Here are the perfect cube numbers: 1, 8, 27, 64, 125, and so on. These numbers are said to be perfect cube because they can be expressed as a number raised to the third power. 1 is equivalent to 1 cube, that is 1 times 1 times 1. 8 is equivalent to 2 cube. 27 is equivalent to 3 cube. 4 cube, which is 4 times 4 times 4, is equals to 64, and that 5 cube 5 times 5 times 5 is 125. For the variables which are perfect cube, we have a cube, b cube, c cube, x raised to 6, y raised to 9, z raised to 12, or any variable raised to a number which is divisible by 3. So now that you have recalled already the perfect cubes, let's have this example: x cubed plus 8. Before we express this in factored form, let us check if the given is a sum or a difference of two cubes. The given terms are x cubed and 8. X cubed is obviously perfect cube. 8 is the same as 2 cubed. We have 2 times 2 times 2. So therefore, 8 is also a perfect cube. These terms are separated by a plus sign. So therefore, what we have is a sum of two cubes. So now we are ready to get its factors. Its factors are two polynomials. One is a binomial, the other one is a trinomial. For the binomial factor, we will get the cube root of the first term of our given. The cube root of x cubed is x, and then we will copy the operation on our given, which is plus. Afterwards, we will get the cube root of the second term, 8. Cube root of 8 is 2. For our trinomial factor, our basis is the binomial factor. For its first term, we will square the first term on our binomial factor. The square of x is x squared. And then we will take the opposite operation on our binomial factor. Since we have plus sign here, we should write a minus sign for our trinomial factor. For the middle term, we will multiply the terms on our binomial factor. X times 2, we have 2x. Lastly, for the third term of our trinomial factor, we will get the square of the second term on our binomial factor. The square of 2 is 4. So therefore, this x cubed plus 8 is equivalent to the quantity x plus 2 times the quantity of x squared minus 2x plus 4. For our second example, let's have 27y cubed minus 1. Let us check our given. 27 can be expressed as 3 raised to 3. Y cubed is obviously perfect cube. 1 can be expressed as 1 cubed 1 times 1 times 1. And we have a minus sign. So therefore, our second given is a difference of two cubes. Setting up its factors, we have a binomial and a trinomial. For the binomial factor, we get the cube root of 27y cubed, which is 3y. Copying the operation on the given, minus, and then take the cube root of 1, which is still 1. Because 1 times 1 times 1 is 1. Next, for the trinomial factor, we get the square of the first term on our binomial factor. The square of 3 is 9, that is 3 times 3, and the square of y is y squared, of course. Now we will take the opposite sign on our binomial factor. We should write plus sign here. Next, we will multiply 3y and 1, which is 3y. And then lastly, we will get the square of 1, which is still 1. Therefore, the answer is the quantity 3y minus 1 times the quantity 9y squared plus 3y plus 1. For our third example, let's get the factors of 64 z raised to 6 minus 125a cubed. Check if the terms are perfect cube. 64 is the same as 4 times 4 times 4, which can be expressed as 4 cubed. Z raised to 6 can be expressed as z squared cubed. Take note that the exponent 6 is divisible by 3. 125 can be expressed as 5 cubed. Obviously, a cube is a perfect cube. So therefore, what we have is a difference of 2 cubes. Setting up its factors, for the binomial factor, we get the cube root of 64z raised to 6, which is 4z squared. Copying the operation minus, the cube root of 125a cubed is 5a. For our trinomial factor, we square 4z squared. Squaring 4, we have 16. The square of z squared is z raised to 4. Taking the opposite operation, we have plus. Multiplying 4z squared and 5a, we have the result 20az squared. Lastly, we get the square of 5a, which is 25a squared. So therefore, 64z raised to 6 minus 125a cubed is just equivalent to the quantity 4z squared minus 5a times the quantity 16z raised to 4 plus 20az squared plus 25a squared. For our trick, let's consider 12 cubed minus 11 cubed. For instance, you're not familiar with the cube of 12 as well as with the cube of 11, but you have mastered already how to square 12 as well as 11. If that is the case, then we can use the technique in factoring sum or difference of 2 cubes, because what we have is a difference of 2 cubes. Writing its factors, we have a binomial and a trinomial. For the binomial factor, all we have to do is to take the cube roots of our terms. The cube root of 12 cube, of course, is 12, and that the cube root of 11 cube is 11, copying the minus operation. For its trinomial factor, we take the square of 12 and then take the opposite operation. Multiplying 12 and 11, we have 132. This operation is always plus, as we have presented on our previous 3 examples. For our last term, we take the square of 11. Now we are ready to perform the operations on these 2 quantities. 12 minus 11 is 1. 12 squared is 144. Copying 132. The square of 11 is 121. Now all we have to do is to add these 3 numbers, and the result will be multiplied to 1, which doesn't have any effect at all. The sum of these 3 numbers is 397. Again, you may use your calculator to input 12 cubed minus 11 cubed, and I'm sure you will get the same result, 397. Thank you for watching. If you like this video, do not forget to click on the thumbs up below. You may also check our playlist regarding special products, and do not forget to subscribe.